Swayam Prabha. Digital India. Educated India.
Welcome dear learners. The video is for the subject of Geography for the course of Bachelor's in Arts with Geography or Bachelor's in Arts with Honours in Geography. The video is for the paper of Climatology. Today we are going to start with the last module of these climatology series, and the topic of the module is classification of world climates. Today in this particular lecture, we will be starting with Koppens climate classification. This is lecture 1A. We have deliberately divided this particular lecture into sections 1A, 1B and 1C because the topic is very lengthy. So for ease of understanding, this particular lecture on Koppens climatic classification is being bifurcated into parts. Lecture 1A, 1B and 1C. The video is being recorded by Dr. Pallavi Upreti. The course coordinator and presenter for the video is Dr. Pallavi Upreti, affiliated to Department of Geography, Doon University. The academic expert and reviewer for the video is Professor Santosh Verma, Head of the Department of Geography, SDM PG Government Degree College, Doiwala, Dehradun, affiliated to Shri Dev Suman, Uttarakhand University. The video is produced and presented under the project name DTH Swayamprabha Channels of MHRD, New Delhi, India. Hello learners, I am Dr. Pallavi Upreti, Assistant Professor in the Department of Geography in Dr. Nityanand Himalayan Research and Study Center, Doon University, Dehradun. We have already covered 6 modules in this particular climatology series, and in the last module, which is module 7, which we'll be starting today, we will be studying the World Climatic Classification. And as part of this first lecture on World Climatic Classification, we will be studying Koppens' scheme of climatic classification. So let's begin with the discussion. In the due course of this particular video lecture, the learners will be able to understand in general the classification of world climates. What is the need to classify the global climates into different categories? And then we will be studying climate classification systems. What are the different approaches which are followed in order to classify the global climatic system? And then we will be studying the Koppen climatic classification system or scheme in detail, the evaluation associated with the scheme, and the relevant modifications which were proposed later on to the Koppen climatic scheme. And finally, in brief, we will be also discussing what are the other important climatic classification schemes that exist to classify the global climates in climatology. So let's begin. Before understanding what climate classification is, we have to first understand what a climate of a particular area is. And time and again in these video lectures, we have discussed what climate is. So briefly, if we understand climate, the climate of a particular area is the synthesis of the environmental conditions, which include soil, vegetation, weather conditions that prevail in that particular area for a very long time period. So when we talk about the variations in climate and weather conditions, they are not random but part of larger order that climate classification intends to establish over a long time period that is prevailing in that particular area. So climate classification are systems that categorizes the world climate. So when we talk about climate classification, it is the formalization of system that recognizes, clarifies and simplifies the climatic similarities as well as the differences which prevail between different geographical areas in order to enhance the scientific understanding of climate. For more than 30 years, the climate classification has been regarded as an essential tool in geography for the teaching of world climate distributions and for regional description also. When we talk about climate classification, several attempts have been made across millennia to classify climates into different categories. Climate classification is important while studying climatology as it is closely correlated with various biomes and is a major influence of life in a particular region also. So why do we need climatic classification? So that we can simplify the similarities and differences which exist in different climatic areas of the world, and we can also study the various aspects which climate influence, particularly related to life which exists in a particular region. And climate classification also gives an insight to the cause of climate and also improves the understanding of related issues that climate influences. So that is also very important, because when we study the classification of climates, it helps establish the cause of a particular climate that exists in that particular area. It gives an insight to it also. And finally, it helps understand the existing variations that occur on Earth because of the atmospheric, lithospheric, and hydrosphere interaction, which makes up the entire biosphere. Whatever interaction takes place between these three components, atmosphere, lithosphere, hydrosphere, it develops a unique climate in that particular area. And therefore, through climatic classification, we can help understand what are these variations and how these variations help in developing a unique climate in a particular area. Now, one of the earliest work of classifying climates comes from ancient Greeks, who have describe the weather depending upon the location's latitude. So a very rudimentary form of climate classification was provided by ancient Greeks, who have tried defining climate based on latitudinal variations. So as we move from the equator towards the poles, they have broadly classified climates into rudimentary broad categories. But in modern times, three fundamental types of climatic classifications are used in climatology. Or you can say that there are different three approaches which are most essentially used in giving the climatic classification of the world. And the first, which is the empirical system of classification, is also the most commonly used method or approach of classifying climates, because it is based on acquired statistical data of climate elements derived through observation and experiment. You can say that it is kind of observation-based climatic classification, which is based on large set of data, analyzing that data, forming association between different elements, and conducting experiments, and then classifying the climate. So it is observation-based approach to define the climates. Second is the genetic system of classification, and these classifications are based on the cause or genesis of climatic phenomena and climatic variation. The second one tends to establish the cause and effect relationship while classifying the climates across globe. The third one is the applied classification, which are those created for or as an outgrowth of a particular climate associated problem. And so it is kind of applied approach which is used to address a particular climate associated problem in a particular area. So these are the three basic types of approaches which are primarily followed in classifying the world climates. The World Climatic Classification have been attempted by several scientists, climatologists, scholars from different fields of study over different time periods. But one of the most prominent climatic classification and one of the initiative to define the global climates was made by Vladimir Koppen, and he was a mature German botanist and climatologist, and he tried classifying the world climates. Besides Vladimir Koppen, C.W. Thornwhite also gave his climatic classification, and he was American climatologist. Third major climatic classification is propounded by G.T. Trivartha, who was American climatologist, but his work was essentially advanced kind of modification to Vladimir Koppen's climatic scheme only. So when we study the climatic classification scheme of the world, these three climatic classification schemes are very important. But the initial most, which was propounded by Vladimir Koppens, remains one of the most important classical work in climate classification system. So in this particular lecture, we will be focusing on Vladimir Koppens' scheme of climate classification. Koppens' scheme of climate classification. Koppen was a Russian-German geographer and climatologist, and he presented his descriptive scheme of climate classification in 1900 and subsequently gave several revisions also to his scheme to improve it and to better represent the global climatic system. His classification is one of the most widely used climate classification and also one of the first successful attempts at simplifying and representing the world climates as part of a general classification. As we have discussed various approaches in the earlier slide, his climatic classification scheme was empirical in nature. That is, it was observation based and it was based on the work of Swiss botanist D. Candolle, who has already given the global vegetation classification earlier to Koppens' work. So his climatic classification was empirical in nature, which was based on vegetation classification or biome classification, which was already given by D. Candolle. So it was empirical in nature. His aim was to devise a formula that would define climatic boundaries in such a way as to correspond to those of the vegetation zones or biomes which were already given by D. Candolle, which were being mapped for the first time during his lifetime. So it was kind of a reverse engineering process wherein, based on D. Candolle's work and his vegetation classification, he observed what are the different kinds of vegetations found in different areas and what are the temperature and precipitation conditions required for those kind of vegetations, and he correlated his climatic zones to the vegetation zones which was already given by D. Candolle, and such type of classification come under the category of empirical classification. So his classification was descriptive, his classification was empirical, and his classification was based on the vegetation classification already provided by the Swiss botanist D. Candolle. Now, keeping in mind the vegetation classification given by D. Candolle, the classification propounded by Koppen is based on the concept that native vegetation is the best expression of climate. So the climate zone boundaries have been selected keeping in mind the vegetation distribution in the background. And Koppen limited his study mostly to classify the climate based on two prominent weather variables or climatic elements, which were temperature and rainfall. He kept it very simple, he kept it descriptive, and he took the most common two climatic elements which affected the vegetation of a particular area also, and which were important elements of climate of a particular area also, that is the temperature and rainfall. Koppen classification is more popular because it was quantitative, though it was very simple, though it was descriptive, but it was also quantitative, where numerical values of temperature and precipitation were considered to delineate the climatic boundaries. He took mean monthly temperature as base, mean annual temperature as base, and annual average rainfall as base. So these two elements, temperature, rainfall or precipitation, he gave utmost importance to these two variables and defined his climatic boundaries based on the interplay of these two climatic elements, temperature and rainfall or precipitation. Since Koppen's scheme of climatic classification was primarily based on major vegetative classes or zones which were given by Candolle in 1874, and these vegetative zones which were given by Candolle had strong latitudinal control, and the vegetative zones given by Candolle were used as the basis of Koppen's climatic classification, primarily because he considered that vegetation is the best indicator of the total picture of climate in general and in particular also. So let's just quickly see what are the 5 major vegetation classification given by Candolle. The first one is megatherms, which represents the vegetation of high rainfall and high temperature areas. So it generally is the vegetation which is found near the equatorial areas. So evergreen type of vegetation corresponds to equatorial areas. Second type of vegetation class given by Candolle was xerophytes, and this is the vegetation of high temperature but low rainfall areas mainly found in the arid dry regions of the world. Third type of classification given by Candolle was mesotherms, and this represents the vegetation of moderate temperature and moderate rainfall areas, primarily corresponding to the deciduous type of vegetation found in the tropical areas. And fourth category is the category of microtherms, which represents the vegetation which is found in the cool temperatures and reduced rainfall areas, and sometimes the precipitation is also in form of snow. So coniferous forest or boreal type of vegetation is the best representation of the microtherms which is found in the higher latitudes. And the fifth and the last category according to Candolle was of hexisotherms, and this is the vegetation which represents the vegetation of cold regions, the vegetation which can tolerate the cold and freezing temperatures with very low precipitation, and whatever precipitation you have in form of snow. So cold tolerating vegetation or very small grasses grow in these regions where you have low temperatures. So these are the 5 categories which were given by Candolle and based on which Koppen gave his climatic classification. Besides taking base of Candolle's vegetation classification, he also devised comprehensive quantitative analysis which was based on average monthly temperatures and precipitation and seasonality of precipitation to categorize the world climates. Taking base of Candolle's climatic classification, he also kind of devised a formula, presented a quantitative analysis to classify the world climates based on 2 particular variables. First one was temperature and the second one was precipitation. Taking base of Candolle's vegetative zones and based on his temperature and precipitation analysis, Koppen presented the division of terrestrial climate of the world into 5 major categories, and he denoted each climatic category with English alphabet capital letters A, B, C, D and E, where each letter corresponds to specific climatic region. The first 5 primary classes according to Koppen were denoted on the basis of temperature variations, which showcased strong latitudinal control also and showcased correlation to the vegetative zones given by Candolle earlier. So you can see that there is a direct correlation between the vegetative classes which were given by Candolle and the 5 major climatic types which were given by Koppen. So let's see what are those 5 climatic types which were given by Koppen. He gave 5 classes and they were represented by English alphabet capital letter A, B, C, D, E, where each letter corresponds to specific type of climatic conditions. So capital letter A represented tropical moist climate, B represented dry climate, C represented moist subtropical mid-latitudinal climate, D represented moist continental mid-latitudinal climate, and E represented the polar climates. And here on the sidelines, you can see that these climatic types clearly fit with the vegetative classes which were given by Candolle. And major 5 climatic types given by Koppen were based on temperature variations, or he said that these were based on temperature variations, although there were little bit anomalies when he gave the classification of B climate, because except B, all the others were categorized directly on the basis of temperature. But primary classification of B climate was not totally dependent upon temperature. We will see in the coming slides. For now, you have to understand that Koppen gave 5 major climatic classification, and the primary classification was based on temperature conditions, which showcased a strong latitudinal control and directly correlated to the vegetative classes which were given by Candolle. Here you can see a little bit more detail about the 5 major climate types which were given by Koppen. A type of climate represented the tropical moist climate, where the annual temperature is always greater than 18 degrees Celsius. Because the primary classification was mainly temperature-based classification, so the A type of climate represented the areas where the annual temperature is always greater than 18 degrees Celsius. B type of climate represented the dry climate where evaporation exceeded precipitation. So the temperature was very high, but you have low precipitation in these areas. Consequently, evaporation exceeds precipitation. Third type of climatic region given by Koppen was moist subtropical mid-latitudinal climate. And the average temperature of coldest month in these particular areas is above 3 degrees but below 13 degrees Celsius. So the range of temperature was between 3 degrees Celsius to 13 degrees Celsius. So you can see that these areas were comparatively at lower temperature than the A type of climate. Then you have D type of climate, which represent the moist continental mid-latitudinal climate, where you can see that the temperature of the coldest month can go below -3 degree and the temperature of the warmest month goes above 10 degrees. So the range can go way beyond -3 also. So approximately -3 to 10 degrees Celsius is the range of D climates. And E climates finally represent the polar climates where you have extremely cold temperatures, where the temperature of the warmest month is always below 10 degrees Celsius. So you can see that the broad classification given by Koppen in A, C, D, E specifically were based on temperature. But in case of B, the base of temperature is not clearly delineated as in case of A, C, D, and E. So B is a special category, you can say, in Koppen classification, where precipitation is given more weightage than temperature. Besides 5 major climatic types, Koppen used following small letters also to give the secondary classification of each category. Okay, each of the primary 5 categories have been divided based on the small letters into different subcategories. Small letter F is used to showcase precipitation throughout the year with no dry season. Small letter M is used to showcase monsoon type of climate with very short dry season. Small letter W is used to show summer concentration of rainfall with winter dry season. And small letter S is used to showcase winter concentration of rainfall with summer dry season. So this is the basis of secondary classification for each of the primary classes as shown here. And the base of secondary classification, as you can see, is precipitation. But again, for B category, separate classes were formed. So when we will discuss each climate in the coming slides, this particular concept will become more clearer. For now, you have to remember that Koppen gave 5 major climatic types based on temperature, where A, C, D, and E were classified completely based on temperature, whereas in case of B, there were some exceptional conditions. Besides this, Koppen also gave secondary classification, which was primarily based on the precipitation, and he used several small letters to give the secondary classification. Now let's say the entire Koppen scheme of climatic classification, where you have your primary classification as A type, B type, C type, D type, and E type, which is primarily based on the temperature variations across latitudes. And the secondary classification of each of the primary classes is based on the precipitation variation. So for each primary class, you have several subdivisions which are based on the variations in precipitation. For example, A type represents tropical humid climate. So within that category, you have tropical wet climate, tropical monsoon climate, and tropical wet and dry climate, which is based on the precipitation variations found within the A type of climate. And similarly, you have for other categories also. Koppen gave 5 major climatic categories, A, B, C, D, and E, and 14 minor subclimatic categories. 5 major categories were based on temperature variation and differences which are found across latitudes, and the 14 minor subcategories of each primary category was based on the precipitation variations. So you can see that A type of climate is primarily found along the tropical areas, while B type of climate is also found along the tropical areas but on the drier side. C type of climate is mainly found along the mid-latitudinal areas, and D type of climate is found along the mid-latitudinal continental interior areas, and E type of climate mainly corresponds to the climate which is found in the polar areas. So you can see that there is a strong latitudinal control when Koppen demarcated the primary categories based on temperature variation. Besides this, later on, another category was added to this basic classification, which was H type of climate, representing highland type of climate. So we will be discussing the H type of climate separately when we will be covering all the climate regions, and we will be understanding why H type of climate was added later on. So let's now discuss all the primary categories which are given by Koppen. The first category in Koppen scheme of climatic classification is represented by capital letter A, which corresponds to tropical humid climate. Major characteristics of A type of climate are it extends between the tropics, which means that it extends from the Tropic of Cancer in the northern hemisphere to Tropic of Capricorn in the southern hemisphere. So the extent is between the tropics, which extend between 23.5 degree north to 23.5 degree south in both the hemispheres. And this particular area, as we have already discussed, it receives high insolation throughout the year, because of which these areas becomes very hot, and high temperature leads to more formation of clouds and high precipitation in the region. As we have already discussed that because of very high insolation which is received in the tropical areas, there is more evaporation, there is more formation of huge towering cumulonimbus clouds, and there is heavy precipitation also. And this particular area is also trade wind zone. Okay, trade winds are continuously blowing in these particular areas. So because of all these conditions, one of the important characteristics is also that it receives very high precipitation. So the winters are practically absent in these areas, and it is a winterless season with warm and moist temperature and precipitation conditions throughout the year, with no distinctive dry season. And the mean annual temperature is always greater than 18 degrees Celsius. So definitely the temperature will be high in these areas, and annual precipitation also exceeds more than 1500 millimeters in these areas. So as you can see that these areas are located along the equatorial belt and extend to Tropic of Cancer in the northern hemisphere and Tropic of Capricorn in the southern hemisphere, receiving fairly high insolation throughout the year. So these are one of the basic characteristics of A type of climate. And in terms of vegetation, you have megatherms, and you have very dense vegetation with evergreen type of forest because of continuous precipitation and high amount of availability of moisture in the soil. So you have evergreen type of vegetation in these areas, particularly concentrated along the equatorial belt. Okay, so 5 degree to 10 degree north and south of equator, you have evergreen forest which are found in these areas. And as you move away from the equator, the precipitation reduces with variations of vegetations found along these areas. The A type of climate is further divided into 3 minor climatic categories based on precipitation. So based on the variation of precipitation which are found within the A type of climate, you have AF type of climate, AM type of climate, and AW type of climate, where A is constant, which represents the tropical wet climate or tropical climate, whereas F represents rainfall throughout the year with no dry season. Okay, AM represents monsoon type of climate, where you have summer maximum concentration of rainfall with a very short dry season, primarily in the winters. And then you have AW, which also represents tropical climate, but the amount of rainfall is lesser than AM in these areas. So they are tropical, wet and dry climate, best known as savanna type of climate. So you have 3 variations Under A climate, first you have tropical wet climate, second you have tropical monsoon climate, and third you have tropical wet and dry climate or savanna type of climate. So let's see what is AF type of climate. AF type of climate represents rainfall throughout the year in the tropical areas. And as you know that the equatorial areas receive insolation throughout the year, and the equatorial areas also have very high precipitation. So the precipitation is throughout the year, and the precipitation even in the driest month is also more than 6 centimeter, which showcases that there is rainfall uniformity. Continuous rainfall is there for the entire year, and these areas are present near the equator, because in equatorial areas where you have very high insolation, because of high insolation the pressure is low and the air is forced to rise up, leading to the formation of clouds and heavy precipitation in these areas. So these areas are also covered with dense cumulonimbus clouds also. Because of continuous precipitation, the daily range of temperature is low. Although these areas receive the high temperature, but because of equally high precipitation, the daily range of temperature is low. And because these areas receives very high rainfall, these areas are dominated by tropical evergreen forest or equatorial evergreen forest also, or in terms of candle you can say megatherms. So this type of vegetation is very commonly seen in the equatorial areas with very dense canopy structure with multi-layer type of vegetation, commonly known as evergreen type of forest. Second minor climatic type is AM type of climate. So annual rainfall is greater than or equal to AF, that is tropical wet climate, but the maximum precipitation is concentrated between 5 to 7 hottest months of the year, primarily because of the existence of high and low pressure systems which lead to very high torrential rainfall during the summertime period. Little rainfall during the winter season is also witnessed in these areas, because of which these areas are dominated by deciduous forests which shed their leaf in a particular season where you have comparatively low rainfall. So monsoon type of climate also experience high rainfall, but the concentration of rainfall is primarily in the summer months. The third category is the AW type of climate, which is tropical humid or tropical wet and dry type of climate. So AW type of climate is more or less similar to AM type of climate, but the main difference is that the precipitation in the wettest month is less than the monsoon type of climate. So if you compare the precipitation which these two areas experience in the wettest months, the AM type of climate will have more precipitation as compared to the AW type of climate. And here also the precipitation is mainly concentrated during the summer season. Because of variations in precipitation, you have mixed to deciduous type of forests which are found in these areas, and they are primarily found along the outer margins of either tropical wet type of climate where the precipitation is less, or towards the drier margins of tropical monsoon type of climate. So it has a very mixed kind of vegetation where you can see the scattered trees also found along with shrubs, and extensive grasslands are also found in these areas. And typically the name given to such areas in the tropical regions is the savanna type of climate. So you can see extensive grasslands with canopies of scattered trees which are found in these areas because of rainfall variations. So along the areas where you will have comparatively more rainfall, you can see a comparatively more dense canopies of scattered trees. But as the precipitation decreases, the trees will convert into shrubs and finally grasslands, depending upon the availability of precipitation. So these are the three minor climatic types within A climate. Now let's see where A type of climate is found along the globe. The AF type of climate, which is the tropical warm climate with rainfall throughout the year. So it will definitely be predominant in the areas along the equator. So along the Amazon region of South America, Central Africa, and regions of East Indies, Indonesia, Malaysia, Singapore, all these areas will have the AF type of climate. And AM type of climate best developed in Southeast Asia regions around India, Myanmar. So all this Indochina Peninsula, India, Sri Lanka, Central and Western Africa region also. And then certain parts of Brazil will have this kind of climate, and northern part of Australia will also witness parts of this climate. So this is monsoon type of climate. And then you have AW type of climate, which is again found in the along the margins of AM and AF type of climate in Africa, India, Indochina regions, and northern Australia. So you have to understand that there is very difficult to demarcate a boundary between AM and AW. But as you know that definitely this is a trade wind dominant area. So the eastern regions will receive more rainfall as compared to the western regions of the continent. So along the eastern regions, you will have more precipitation. So as you move towards the inside of these areas, you will have savanna type of climate with reduced precipitation where trade winds loses moisture as they move inside the continents. So along the outer margins or along the westward margins of AM type of climate in the continent, you will find AW. Or as you will move towards the continental interiors, the AM type of climate, because of reduced precipitation as you move from east to west, will transform into AW type of climate. So here in this particular world map, you can clearly see the concentration of A type of climate is primarily along the tropical areas extending between the Tropic of Cancer and Tropic of Capricorn, wherein AF is primarily located along the equatorial belt and AM is located along the margins of AF, and further AW is located along the drier margins of the AM type of climate. So this was all about A type of climate. Now let's move on to the B type of climate, which corresponds to dry climate in Koppens climatic classification. Let's discuss the features of B type of climate. Major characteristics of B type of climate is that it is denoted by capital letter B and it extends in the region around the tropics between 20 to 35 degrees in both the hemisphere. We have already learned about the characteristics of A type of climate, which is tropical moist climate, which also extends between the Tropic of Cancer and Tropic of Capricorn. But as you move away from the equatorial areas or tropical areas towards the Tropic of Cancer in the northern hemisphere and towards the Tropic of Capricorn in the southern hemisphere, we know that these regions are characterized by anticyclonic conditions, which means that although these areas receives very high insolation throughout the year, we have studied in module 3 that these areas are subtropical high pressure belt regions of the world, and the reasons we have already discussed why they are subtropical high pressure belt regions. They are dynamically induced subtropical high pressure belt regions with anticyclonic conditions, which means that the air and the ground surface tends to diverge from these areas. Therefore, they are characterized by high pressure conditions, anticyclonic conditions, atmospheric stability, and aridity on surface, because of which the evaporation exceeds the precipitation, leading to dry and arid conditions. So these areas, although they receive very high amount of insolation leading to high temperature, but at the same time there is low precipitation also because of existing anticyclonic conditions or arid conditions along these tropical margins. And such type of climate is predominant. But along these belts also, if certain areas are located along the continental margins, so continental margins may still receive some kind of precipitation due to some kind of regional cyclonic activity, regional dynamics of temperature and pressure differences, but the arid conditions are very much predominant in the interior regions of the mid-latitudes along the tropics or along the western margins in the subtropical areas, because these areas are completely devoid of any incoming moisture laden winds also, and the continental interiors experience high pressure anticyclonic conditions leading to atmospheric stability. And in Koppens classification, such type of dry areas with very less rainfall and high temperature are represented by English language capital letter B. Now, the B type of climate is further divided based on annual precipitation and precipitation in the rainiest month of the year into two broad categories. The first category is the BW category, which represents dry desert type of climate. So this is the true desert type of climate where you have very low precipitation and it is primarily dominated by the xerophytic type of vegetation, the cactus plants, the succulents which are found in the regions, and it receives rainfall as low as 25 millimeter to 200 millimeters also. So it is a very, very dry region and represents the true desert type of climate. In these regions, the diurnal range of temperature is also very high because during the daytime period, the temperature is very high, whereas during the nighttime period, the temperature becomes extremely low. So the daily range of temperature is high in the BW type of climate. Coming to the second category, that is the BS type of climate, which is semi-arid dry climate. So these regions are dry, but they receive a little bit more rainfall than the BW type of climate. So dry climatic regions, but receive precipitation higher than BW, either in form of trade wind convergence leading to torrential rainfall, or from the mid-latitudinal cyclones also you can receive rainfall in the mid-latitudinal areas or semi-arid regions of the mid-latitudinal areas. Because the precipitation is more, these areas can support small and scattered type of vegetation in form of scattered trees, shrubs and grassland vegetation. So these areas are drier regions but receive comparatively more rainfall than true desert areas. So therefore they are semi-arid in nature. Now the subcategories of B type of climate, that is BW and BS, are further subdivided on the basis of annual temperature conditions. So when the mean annual temperature is greater than 18 degrees Celsius, it is indicated by small letter H, whereas when the mean annual temperature is less than 18 degrees Celsius, it is indicated by letter K. And this type of arrangement is specifically done for B type of climate. As we have studied in the earlier slide, that the two subcategories of B type of climate was BW and BS type of climate. And based on annual temperature variations, these two categories are further subdivided. So the BW type of climate is further divided into BWH and BWK. It symbolizes that the temperature in the desert regions is more than 18 degrees Celsius, which means that these desert regions are mainly located along the tropical areas where the temperature is more than 18 degrees Celsius. They represent the tropical desert climate or true desert climate. These areas often witness the short intense rainfall, and annual precipitation generally ranges between 0 to 25 centimeters only, because of which these areas are predominant along the western continental margins in the subtropical high pressure belt regions of the world. So you can have desert type of climate or moisture stress conditions not only in the tropical areas also, but also along the higher or middle latitudes. So BWK represents the moisture stress areas which are located in comparatively higher latitudinal zones where the mean annual temperature is less than 18 degrees Celsius. You can say that these are the regions of mid-latitudinal cold desert areas, and the annual range of temperature here in these areas is very high, which may range from minus 20 degrees Celsius in winters to even 20 degrees Celsius in summers. And most of these areas lie in the rain shadowed zone in the interior regions of the continent in the mid latitudes where the moisture or rainfall is minimum. So within the BW category, you have tropical deserts or the hot deserts, and you have the cold deserts or the mid-latitudinal cold desert areas. Second category was of BS, which represented the semi-arid dry climate areas. Along the desert areas where the precipitation is little bit higher, you will have semi-arid conditions. The areas will not showcase true desert features, but similar to semi-arid conditions will prevail in those areas. So the semi-arid dry climate again can also be witnessed in the tropical areas as well as in the mid-latitudinal areas. So BSH represents the tropical grasslands where the temperature is more than 18 degrees Celsius. So the tropical grassland regions are represented by BSH. BS means the semi-arid regions and H means where the temperature is more than 18 degrees Celsius. Because of the low precipitation in these areas, they support little bit of vegetation. You may have shrubs, grasslands and stunted trees also in these areas. And these areas are generally along the margins of desert type of climate. Coming to BSK, which represents the semi-arid dry climatic conditions in the middle latitudes, because K represents where the temperature is less than 18 degrees Celsius. So even in the middle latitudinal areas or continental interiors where the moisture is less, you may have semi-arid conditions. But if the moisture will be very less, it will turn into mid-latitudinal cold deserts. So along the outer margins of the mid-latitudinal cold deserts, you will have BSK or mid-latitudinal cold steppes type of climate or temperate grassland type of climate. So precipitation in these areas will be less, but it will still be more than BWK, that is the mid-latitudinal cold deserts. These temperate grassland regions are generally found between 30 to 60 degrees in north and south of equator, where you have little precipitation in the mid-latitudinal areas. So these are the four categories within the B type of climate, which represents the hot desert type of climate, mid-latitudinal cold desert type of climate, and you have semi-arid dry climate within which you have tropical grasslands and you have temperate grasslands. Now let's see the distribution of B type of climate in world map. So BWH, that is the hot desert type of climate, is definitely found along the Tropic of Cancer and Tropic of Capricorn region in both the hemispheres. So you will have pockets of Chile, Mexico, southern USA, North Central Africa, Arabian Peninsula with Arabian Desert, Central Australia and parts of India along the western margins, Balochistan area in Pakistan also. So these areas have hot desert regions. Besides this, cold deserts are found in the areas of middle to higher latitudes. So you can see pockets in North America, South America, along the coast of Chile and Argentina, Patagonia Desert, and pockets of cold desert in Central Asian region, Turkmenistan, Mongolia, Western China, and certain parts of Central Asia. Here you can see that these areas are located in so interior regions of Asia that moisture cannot reach in these areas, and even these areas lie in zones of 30 to 60 degree latitudes, but these areas still remain in moisture stress, making these zones as cold deserts of the world. So this is the distribution of hot deserts and cold deserts. Besides hot and cold deserts, along the margins of hot and cold deserts, you will see the subtropical grassland areas also and temperate grassland regions also. Along the wetter margins of the BWH and BWK, you will find BSH and BSK respectively. Just observe how most of the tropical deserts are located along the western side of the continents primarily. So one of the prominent reasons in support of this is that trade winds do not bring moisture to these areas, but rather move out from these areas, and therefore these areas always remain in moisture stress situation, leading to dry desert type of conditions. And second prominent reason is that this particular belt is subtropical high pressure belt. So at ground level, you will always observe high pressure conditions where the air move out from these areas, leading to high pressure conditions, arid conditions, anticyclonic conditions, and hence moisture, stress, or low precipitation is observed in these areas. You can also see the distribution of grasslands, temperate grasslands and tropical grasslands. So you can see that these particular grasslands are located along the margins of desert areas. So subtropical grasslands are found in South America, Africa, India, Australia along the desert margins, which receive slightly more rainfall to support vegetation. Similarly, the temperate grasslands which are found in Europe, America, Africa, and Australia are also found along the wetter margins of the cold desert regions, which receives more rainfall. So this was the distribution of B type of climate or dry climate. In part A of Koppens scheme of climatic classification, till now we have discussed A, tropical humid climate and the subcategories of tropical humid climate, and B, dry climate and subcategories of dry climate. The remaining C type of climate, D type of climate, E type of climate, and highland type of climate will be discussed in the part 2 of Koppens scheme of climatic classification. Thank you for now.